Alright, sorry guys, I thought I'd actually set up the stream already. Completely forgot that I didn't actually set up the stream until I started getting messages, and I looked up and I didn't, yeah, there we go. Sorry, and I also had to put slow mode on because I think there's gonna be a few people coming, but let me just clear a few messages. So guys, the things that we're going to be focusing on today is what is this? We're gonna do an exponential equation, all right? Just a quick little exponential equation kind of survival guide to it, and then it's going to be a really short session today, just exponential equation, and then if anybody wants quadratics or linear, just check out the two previous tutorials that I've done. I've pretty much covered most of it there. Yeah, so that's what we're going to be doing. So we'll wait for about I think we'll wait till about 7:40, and then we can kind of just kick things off slowly. Sorry guys, I completely forgot that I didn't actually put this little link up and got everything ready. So yeah, few messages coming at the moment on right now. I was wondering why my Instagram was kind of like going off, but still doing a level 1 TG and GR tonight. Yes I am, I'm doing it right now. What else? Blah 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 blah. Okay, so we got a couple of things coming through. What are we doing? Man, I got questions coming in like 3 different directions. I don't even know where to start from. And then they're all coming with like little titles of important question. Okay, so this question is, I might actually do this. I don't know if Will, you're actually on the stream. TEG graphs tomorrow. When we answer, say, a question that says find the equation of a parabola, do we have to show a working do vertex form in order to get the full mark, or any mark at all? Okay, look, if they ask you guys to find the formula for a parabola, then you can just put it in the graphics calculator and get it in just normal ax squared plus bx plus c format. Now normally I actually, I'm just gonna be right back. Just where are we at? Splash. No, wrong email. Here we go. Okay, Aaron. Small world, Aaron. Small world. I think there's a shout out to you. The shout out that actually goes to Aaron because, yeah, long story short, I worked with DAF for a small period at the Air Force, so that was quite a bit of fun. But yeah, I'm glad you found the thing, man. Found the site here and just kind of working through it. But look. Here's what we're going to do. We're going to do exponential equation, and I want to finish off after that by doing a very quick bearing/trig question, because it just means that if people are not doing geometric reasoning, they can kind of move on and just kind of go away and just start working on the exponential equation. Now guys, I'm gonna be honest, I actually can't, I struggle to cope with the amount of questions that come through, and if I don't get to your question, I do apologize. It's like the busiest time at school for me with prize giving and things like that, so yeah, I do apologize about that. Now, in terms of what the paper is going to look like, I have absolutely no idea what the paper is going to look like. I mean, you know, all we can do is just prepare, practice, and pretty much be ready for whatever comes our way. That's all I can tell you. So yeah, I mean, like every year it's always the same thing, like people going, oh yeah, this paper was hard, this paper was hard, this paper was hard. But if I look at the algebra paper for level 2 today, it was the achieved and merit questions are fairly straightforward. It's the excellence questions that ends up being quite tricky. Now, if you're just joining me and you're like, I haven't done any study at all and I've got like 12 hours to get myself ready for this exam, if there's anything I'd recommend is maybe when this stream is finished, go back and watch the linear and quadratic from this playlist. All right, and what do I mean by this playlist? Let me just show you guys where this playlist is, and then yeah, so if you just go into my channel, like where is my channel? So under my channel, if you go into live videos, what you'll notice is that I've actually done like a couple of ones. So like if you see, even if that's this one here, which is the 6th, I think this one I need to rename it. Sorry, let me just rename that to 9th. I just reused the settings there, that's why. So if you want, you can actually just head over to the tutorial that we did on the 6th and the 2nd. That's linear, that's quadratic, and that's exponential right now. And that should definitely at least get you guys to an achieved level at least. Okay, step graphs. How many decimals? Jack, you want to be sticking to like 2 decimal places for step graphs. That's always good enough. There you go, Mr. Ong's videos for chance and data. All right, let's get started with the exponential one. All right, now this one here, unfortunately, I've been playing around with it for a while to try and figure out if there is a way to do on the calculator. And to be honest, I just gave up in the end and kind of came up with my own little shortcut there. ARX plus C. And R is going to be 2. And C is going to be 0. All right. So what we're going to do is I'm going to do one quick little example, guys, and then after that we'll actually kind of get through with this things. All right, so just give me a second. I'm just setting up a question here. Okay, so excuse me, the first question we're going to be doing is the exponential ones, right? And again, a lot of people end up asking me this question: how do I how do I get the equation from an exponential graph into an equation? So what I'm going to do is I'm going to switch over this for you guys. Hopefully you guys can see this, right? Because it's a bit annoying, but hopefully it works. 50. No, you only need 3 points. All right, let's see. I'm going to show you guys this graph here, and then I'm going to ask you guys to come up with the equation for this graph. And the points are, now I'm just going to leave the graph as is. Okay, so here we go. Where's the thing? So there is my graph right now, and what I would like you guys to do is come up with the equation for this. All right, so I guess the first step you really want to be doing is making sure that you actually can get all the points correctly, and once you get the points correctly, then I can actually show you guys how to get the equation for this graph. Without graphics calculator. Moonstone, I'm sorry, like I know I did some questions before with the graphics calculator. I took some time in 2021 to make sure that I did both methods, so I did graphics calculator and without a graphics calculator. So off the top of my head, I can't actually I can't remember what the question looks like. All right, so without further ado, let's actually get started with this particular question. All right, now with exponential graphs, what you want to be doing is like you want to make sure that you get like a few points. All right, in here we've actually got 3 points that we can work with. So what I'm going to do is I'm going to write down x, and then I'm going to write down y, and I'm going to write down those values. So I've got 0, 2, 1, 6, and 2, 18. All right, so all I've done is I've taken those 3 values and I've kind of made a small table for it. Now, the next thing that we can kind of do here is have a look at these numbers. All right, so if you look at these numbers, particularly I'm looking at the difference between 2 and 6, right? Like if you look at it, the difference between 2 and 6 is it's actually going up by 4, so it's actually plus 4. And then if you look at the next one, 6 and 18, it's actually plus 12. Now I don't have the graph for you guys for 3, but at 3 it's actually equal to 54. And what you'll notice is the number is actually increasing by 36. And I guess this is like one way to kind of look at it and go, yep, I can see that this is going up very quickly, very fast, therefore it's going to be an exponential equation. Mainly I'm looking at these numbers here. It's actually 4, 12, and 36. And we know that what's happening between those numbers is it's actually increasing by 3 every time. All right, now our equation for the exponential, and again your teachers might have given you a completely different equation, and if you're comfortable with that, that is absolutely fine. There's nothing wrong with that. But if you've kind of been like stuck and you're like, I don't know where to go with, I always use this one here, which is y equals ARX plus C. Now I've kind of given you guys a bit of a easy start here, because I've actually given you what the C value is. Because remember, if you actually have 0, 2, like, because y-intercept is when x is equal to 0, so I can straight away say that C is actually equal to 2 in this case, because it's cutting the y-axis at 2. And it's kind of evident if you look at it in the graph itself. So in the graph here, your graph is actually cutting the y-axis at 2. So that's the C value right there. So it kind of makes things a little bit easy for you. All right, now coming to the R. What is the R? Now there's a particular reason why I put the times 3 in red. The reason I put it in red is because it's kind of obvious here, because R stands for the ratio of increase. So that's where that red number is going to go under. So what you're going to end up with is y is equal to a times r, which happens to be 3 to the power of x plus c. Eurolink, thanks man. You didn't have to pay me, but like, that's appreciated, dude. Yeah, I remember a couple of years back somebody was talking about it. It's like you watch this for 3 years and then it's done. All right, so we know what C also is, because we know that C is equal to 2. So we can actually leave that as positive 2 there. Now we need to figure out what A is. So to figure out what A is, we need to pick a point, and we can pick any point. We can pick 116, 218, or 354. I'm actually going to pick up. I'm going to pick up 218. Who was this asking? Me. You could just divide the second number by the first and you'll get 3. Me. Yes, that would work if you actually. Dude, wow, like seriously, Initial, I think you must have forgot a decimal point there, buddy. Like seriously, thank you, but you don't need to, man. Jeez. Not much. Thank you, Initial. That's all good, man. But you don't need to. But yeah, let's stop distracting me and let's get back to work. So I'm gonna choose 218, right? I'm gonna go back to me. Me, you asked me like, could you just divide the second number by the first and you'll get 3? Now, unfortunately, it doesn't work in all cases, and I'm going to show you guys in the next example of why it doesn't work. All right. So we're going to put down 2 and 18. So this is going to be 18 is equal to a 3 to the power of 2 plus 2, and then what you have is basically 18 take away 2. John, yes, C value is basically when, and that works for parabola, it works for straight line, it works for exponential anytime you get that c value, because if you think about it like this, right, when you have a straight line, you have y is equal to mx plus c. That c is actually when it cuts the when the graph cuts the y-axis. And if you think about a parabola, you're going to get ax squared plus bx plus c, and once again that little c value is when the graph actually cuts the y-axis when x equals to 0. But anyway, let's go back to here. We're going to go 18. We're going to take away 2 from it. Now, have I made a mistake here? I've done something wrong here. ARX. Okay. That's all right. Let me just redo this again. I think I might have just... What did I do here? Why is c equal to 0? Yeah, I know what I did wrong. Sorry guys, sorry. Yeah, I know where my mistake is. Apologies. Like, we're gonna try that again, but let's actually go with the old-fashioned method. Like, I don't think I'm gonna do this. Let's try this. Sorry. I stuffed that up. Now, I know why, because I know why I did this mistake. Now, the reason why it's not gonna work in this situation, because we still have to figure out what the A is, and so we can't just make it up. So I'm gonna do this slightly different. So just be patient with me. It will work out. Yeah, I messed it up. I messed up a little mistake there, but that's fine. So I've got this equation here, right? Because that's actually going up by 3. That's the ratio it's going up by. And I still need to figure out what A and C is. So I'm sorry, Carmel. I'm sorry. But what you can do is we're gonna have to use like simultaneous equations for this. So I'm actually gonna use 0, 2 first to kind of show you guys what's happening here. And I think I know where my mistake is. So when I use 0, 2, what happens is I get y is equal to 2 a times 3 to the power of 0 plus c. Now 3 to the power of 0 is 1. So what I've actually got is a plus c is equal to 2. So here's where I made the mistake. Nishal, sorry mate, thank you, but like you really need to chill out. Just take it easy with that, man. Like, jeez. Is see the y-intercept, not like I forgot, I've made a silly mistake. In exponential, it works slightly differently because of the a value. All right, so I'm gonna choose that as 1 point. My next point I'm gonna choose is 6, 1. So what I'm getting is, sorry, not 6, 1, 1, 6. I am gonna get 6 is equal to a 3 to the power of 1 plus c. So what I've got is 6 is equal to 3a plus c. So basically I've got 2 equations here. My first equation is 3a plus c is equal to 6. My second equation is a plus c is equal to 2. So because I have that, then what I can do is I can just subtract everything because it's just simultaneous equations. And you don't need a graphics calculator, or you don't need any type of calculator for this, because it's just like you setting up a really simple equation. So you got 3a take away a is 2a, c minus c is 0, 6 minus 2 is 4. So what we're getting is a is equal to 4 divided by 2, so a is equal to 2. Now we also have this other equation that a plus c is equal to 2, which is from here. So we can actually say 2 plus 0 is equal to 2, therefore c is equal to 0. So if I go back to my equation, I've got arx plus c, which means I'm going to get 2 times 3 to the power of x plus 0. So I guess, I mean, I knew there was like something was wrong. Like, this is what happens when you don't get enough sleep. Yeah, Scribble. I think we literally just did that because I actually started from the graph itself. So if you look at it, I actually had the graph and I took like 3 points, and then I converted the 3 points into a table, and then from the table we actually got to the equation. I've already done lots and lots of practice papers. If you go to the main page of my site, you will find it. So have a look. Nishal, I appreciate the love, man, but it's okay. Just buy something nice for Christmas for your folks, yeah. With quotes, I'm sorry I missed that. What's the equation for a quadratic? Like quadratic, I think I did that in the last tutorial, guys. So you could use ax squared plus bx plus c, or you could actually do vertex form as well, and I think that'll be quite handy. Look, let's do one more exponential equation, just getting from the graph to the equation, and I'll put it up there for you guys. So, and I'm going to change it up a little bit just to make it just a little bit interesting or trickier. Let's go with that. That's fine. So I'm going to give you guys one more question, but I need to give you guys some nice points. Yeah, okay, so try this question here. Donkey123, we did that in the other tutorial prior to this, alright? So, okay, so I've got one more question for you guys, and this is the last exponential question we're going to do, just so that we're not getting confused, right? Like, I know I kind of botched the C thing in that last one. I was just tired, sorry about that. But here we go. Pick 3 points, and then 3 or 4 clear points, right? Like, I wouldn't actually pick this point here. That's kind of like in the middle of nowhere, but I would pick this one, and this one. So what I'll do is, if you guys, I'll give you guys like maybe 3 or 4 minutes just to have a go at it, and then after that I will kind of go through the answer with you guys, and in the meantime I'll try and get to some of the A is the y value when x is 0. Yeah, true. Jeez. But it depends, right? Calculator. Can't you just do it as y equals arx and a is the value of y when x is the rate of change? John Arthurs, you can do that, but like, see, I've actually given you guys a slightly one more tricky question, because I've actually moved this graph up, and because I've moved the graph up, you're gonna have to try and figure out that c value this time. I think if I remember correctly, now it's kind of slowly coming back to my memory. For the exponential, the c value is actually kind of like where the exponential asymptote is. So like that right there, see how that's never gonna reach +1? So I'm thinking like that's, yeah, I know, now I remember. Geez, I know, talk about coming slow today. That's where your the c value is for exponential curves. Ian, yes, I think you do need to remember. Yeah, Dallas, I had a look at the paper. I mean, it wasn't like what do you call it? I mean, the excellence questions are meant to be tough, right? Like, you're not going to get like easy excellence questions, but yeah, like the achieved in merit was fairly straightforward, and I was like, oh, that looks all right. so where are we up to? Man, I did that question, Minties, I did that question in the live tutorial, like when I did it on Saturday when I was doing some work with some people, and I don't have my notes here with me for that question, Minties. Alright, let's go through this question here. Alright, so I'm going to get some points here, and as I said to you guys, I'm going to grab my X and Y points. I've got 2, 2, and I've got 3, 3, and I've got 4, 5, and then I've got 5, 9. Okay, so let's go back to the main space. So what I've got here is, if I look at my the difference between my numbers, it's going up +1, +2, and +4. So basically all of these numbers are getting multiplied by 2, which means R is equal to 2. So I can actually put this down as Y equals ARX plus C. Because R is equal to 2, I can put 2X plus C. Now what I've got to do is I've got to substitute both 2 points to get like a set of simultaneous equations, and then I can actually work from there. So I'm going to use, the first point I'm going to use is 2, 2. So when I use 2, 2, I'm going to get 2 equals A, 2 to the power of 2 plus C. And in here I've got 3, 3. So I've got 3 equals A, 2 to the power of 3 plus C. So my equation is going to be 4A plus C, and then 3 is equal to 8A plus C. So I stack them on both of them on top of each other. So I've got 8A plus C equals to 3, and 4A plus C equals to 2. Man, I'm botching things today so badly, eh? Nah, it's alright. This one is all going to be okay. So then what happens is, now here's the thing, right? Like I purposely made this question different, and I want to show you guys, go back to the question and show you guys the actual equation. The actual equation is going to look something like this, and I did make it a little bit harder for you guys, but that's okay because it still works, and that's what I wanted to show you guys. Even though the equation is this, when we actually work it out, it's all gonna kind of work out fine. Because what are we gonna get? We're gonna subtract this. Nishal, you can just ask questions, man. You don't need to keep tagging me on that. Yeah, you wouldn't get less grades or anything like that. You would still get the same grades. But I think some questions, they actually make it so that you need to use more than a graphics calculator. So I got 8A take away 4A, which is 4A. C take away C is 0. 3 take away 2 is 1. So what I've then got here is A is equal to 1 divided by 4. Now once I get that, I can actually go into my equation like 2 is equal to 4A plus C. 2 is equal to 4 times A, which is 1 over 4, plus C. So 2 is equal to 1 plus C, and we can see that C is equal to 1. So my equation is going to be Y is equal to 1 over 4, 2 to the power of X, plus 1. Now if you look at my answer in Desmos, what I had done was I actually got 2 to the power of X minus 2. Now if you remember in algebra, like this is still the same thing. You can actually leave your answer here, guys. You don't need to go any further, but you can simplify it, because this would just be 2 to the power of X, and 4 can be written as 2 squared. And then we just use index rule to write this as 2x minus 2 plus 1. But you can leave your answer right there. Alright, so I'm just picking random questions here. How do we know some questions we can't use graphics calculator? Well, I think it depends, right? Like once you start working on the questions, you'll be like, well, actually, like if you say, for example, you're doing like a algebraic question, like where they have like moving x units up or x units down, then you can't use a calculator for that. You would have to actually work it out using manually, like doing it algebraically on paper. Tarun, yes you can. If you go to this, by the way, here's a useful playlist for you guys. Where is it? Out here. So if you guys go into just at my homepage, and if you go right down, there is about 8 videos on graphics calculator tips and hints, and this is useful for TEG. This is useful for TEG. This tables equations, tables equations, tables equations, tables equations. So you've got all of these 1, 2, 3, 4, 5, 6 videos there that you can actually watch to find for tips on graphics calculator. Yulia, no, you will not get marked down. You could have written that exponential equation in any particular way. Do we have to change? Not for tables, equations, and graphs. You don't need to change your calculator from radians to degrees, because unless you're doing geometric reasoning, then you need to change it to degrees. Otherwise, it doesn't really matter what, like you wouldn't be using degrees in tables, equations, and graphs. So, Raina Kim, how do you solve stuff like 200 equals 1.5? That's a good question. So, I think it was 200 equals 1.5 times 2 to the power of x. Now, considering you guys will not have actually used this calculator for that, because I don't think they ask you for like 2 to the power of x. I don't know, who was it that asked me that question? Yulia? No, Raina. Raina, you asked me the question here, right? Like this question here. Let me just go flick it over. Usually this question here is in level 2, but if they do ask, for some reason you get asked that, you can actually go into equation and you can click on solver, which is F3, and just write the equation down. So you just go 200 and put it as equals 200 equals 1.5 times 2 to the power of x. Oops. And when you click enter and then click on solve, you should get the x value for that. So you can just say x is equal to 7.059. Now this part you can actually use a graphics calculator for, but like I said, this is actually level 2 stuff. They really shouldn't be asking you this type of questions, and if they do, that's pretty nasty, to be honest. It's good. What do you, Krish, I know you keep popping up with that question. What if the values aren't integral, bro? Krish, are you talking about graphs that are like, not integral, what do you call them? Discrete. Like I said before, that only works if the C value is actually 0. No, exponential equations, I don't think they can be done on a graphics calculator. Ben, because for that question, C was actually equal to 0, so 2 to the power of 3x was actually correct. Alright, some real quick crash courses, guys. Does it matter which equation you subtract? No, Gabriela, it wouldn't matter, because eventually you'll still get the same A value. Patricia, no, you can't use it for everything, but you can definitely use it for some of the stuff there. Okay, look, you guys got a choice, guys. I mean, we can actually do one more exponential equation, or we can do a step graph. What would you want to do? Do you want to do one more of this type of question, or shall we actually do a step graph question? Okay, tell you what, we'll kind of do both so that people can kind of work around it, because obviously you guys are all over the place at the moment with what you want to do. So with the exponential one, what I'll do is I'll actually put up the exponential one on this side, and those of you that want to work on the exponential one, you can kind of work on it slowly. And on this side of the board, I'll actually do a step graph, real quick example of a step graph. All right. Okay, so I'm not going to make it too complicated for you guys. I'm just going to give you guys a really nice set of numbers, and then we'll kind of let that be done. So we shall do let's try this. Alright guys, I'm going to give out 3 points for the exponential one, which is you've got 10, 20, 40. Okay, so for those of you guys that want to try and do exponential questions, you can do it, which is going to be on the left hand side of the board, and then for the right hand side we're going to be doing a little step graph. Oh no, is that what's been happening? Jeez, I completely forgot to switch my mic. Is that better? Well, none of you guys actually told me that my voice was like, the mic was actually moved away. Oh, I'm so sorry. Oh, thanks. Who was it that actually picked it up? Yeah, sorry guys. I normally have the mic moved up and I completely thank you for picking it up. Thank you for picking it up. All right, okay, there we go. Sorry, I'm so sorry about that. Like this. Yeah, but anyway, while you guys are actually doing the exponential graph, I'll actually work on the step graph, all right? Now, with the step graph, I'll tell you guys, sorry, Carmel, yeah. With the step graph, you're going to have like situations, right? And I think there's two things I'm going to talk about here. One I'm going to talk about is step graph, and then one is a discrete graph. So it all depends on your question, right? What do I mean by step graph and discrete graph? With step graph, the graph actually ends up looking like these kinds of things, right? Discrete graph actually just looks like a bunch of points. So at what point do we actually use at what point would you actually do which one, right? So a classic example that I always give my students back in the day was this. If I think this is something that happens still at the moment, like if you go to like any kind of moving company and things like that, they basically say, look, for the first hour we charge like, I don't know, $150, and then after that we charge like $75 for every half an hour. All right, so if you think about it like this, let's charge $150 for the first hour, and then I don't know, like let's say $60 for every half hour after that. So it kind of works like this. So if you think about it like a table, what happens is I'm kind of going to put this as time and cost. So between 0 and 60 minutes, it's going to cost me $150. Between 61 minutes and 90 minutes, it's going to cost me $210. Between 91 minutes and 120 minutes, we're going to get $70. So when we go to the graph, what we need to do is this, and people get confused about the open and the closed thing, right? But basically what I'm going to do is I'm going to put down 0, 30, 60, 90, 120. That's enough for now. And then here I'm going to go up in 30s. So I've got 30, 60. Oh man, no, maybe not that. Let me just go up in, what can I go up in? I'm going to make this a rough scale, guys. Sorry, I just keeping in mind of time at the moment. So let's say that's 270, 210 minus another 60. That's going to be 150. like just roughly, all right? It's a rough little graph there. So what happens is between 0 and 60, it's actually $150. So between 0 and 60, it's going to be 150. But between 61 and like 60 and 90, or like you can kind of say the moment it crosses 1 hour, and I really should have put like 60, but like this is just to give you an idea, right? The moment it crosses 1 hour and we go into that second hour, we're going to be charged $210. But that's going to be put as a little hole there. All right, and then between 90 to 120, we're going to put a little hole there, and then but it's going to be filled up at the end at 120. So really all you got to do is just make sure you look at the question and the type of like, how do I say it, whether you actually include the point or you don't include the point. If you put a circle, that means you're not including the, like a empty circle, then you're not including the point. If you're putting like a filled colored circle, then you're actually including the point. All right, so that's kind of like a quick little idea of what a step graph is. So really, when you look at the question and they ask you like, oh, what's gonna happen in this situation? So you got to look at the situation and go, okay, is this a situation where I'm going to draw it as a straight line? Is this a situation where I am going to actually do a step graph? Or is this a situation where I'm going to do a discrete graph? So what's an example of a discrete graph? An example could be something like, every day I get $5, all right? Which means I get $5 more. So if I put this as X and Y, day 1 I get $5, day 2 I get another $5, day 3 I get another 5, 15, and so on. But if I was to put this as a graph, then that would be 1, that would be 5, that would be 2, that would be 10. I wouldn't actually join the dots in this case. And the reason I wouldn't join the dots in this case is because I am not getting $7.50 for 1.5 days, because I'm getting that whole $5 at the end of every day, which means I can only get the money at the end of the day. I'm not going to get it actually during the middle of the night or anything like that. So in this case, I wouldn't actually join the line at all. All right, I wouldn't join the line at all because I'm not going to get $5.91 at some point during the day. So this is what we mean by like putting it as discrete points. All right, Daniel, thank you for that, but you could have just asked that question without dropping anything. But if you run an answer, do we have to write that we have rounded the answer, or is the answer good enough on its own? I think the answer is good enough on its own, buddy. So that's the difference between that step and what's the 50 sub special? I don't know what that is, Cookie. Anyway, that's the kind of like the two different types of discrete and step graphs, right? I'm going to go back to the exponential one. The exponential graph, like if you guys have a look at it, just doing it quickly, we've got plus 10, plus 20, plus 40. What's happening is everything is getting multiplied by 2. So r is equal to 2. So I can rewrite this now as y is equal to a 2 to the power of x plus c. And I'm going to take down the point 110, and I'm going to take 220. So I've got 10 equals a 2 to the power of 1 plus c. And on this side, I've got 20 equals a 2 to the power of 2 plus c. So I've got 10 equals 2a plus c, 20 equals 4a plus c. I'm going to stack them on top of each other, and I'm going to subtract it. So when I subtract 4a minus 2a, I get 2a. C minus c is 0. 20 take away 10 is 10, which means I get a is equal to 5. Now, if a is equal to 5, I go back and put it in one of the equations, and I've got 10 equals 10 plus c, so therefore c is equal to 0, which means my equation is y equals 5 times 2 to the power of x plus 0. So, oh, hang on, what did I just do? All right, so that is pretty much a quick example for exponential one. I hope that you guys have actually kind of got it. Samuel, I don't know, man. Like, you know, it's kind of hard to try to do any kind of predictions. Like, I think I did a prediction once in 2017 for a question. Yeah, that was the only time I did a prediction, but the rest of the time I've been pretty stink with my predictions, to be honest. Amreen, I kind of just explained that just now, a few minutes ago, so you might just have to wait till the stream is over and just try and get to this timestamp around 8:20. I think 8:20 I was explaining it. So yeah, you should be all right. Well, Gabriela, I guess you can kind of call it a step graph, but it's just like, you know, I think I put that as discrete because it's like it only works for those particular values. But if you look at the step graph you can actually get for 61.5 minutes. But yeah. Hey, Eric Rollers, welcome back, man. We're doing differentiation. I think we're doing a couple of excellence questions after this. Okay, look, similar triangles. I think that's us for TEG, guys. I just want to do a quick session, very quick one on similar triangles, because I know that a lot of people have been asking for it, and then it's kind of very useful to have as well. So similar triangles, there's only one thing you need to really remember, and I know people kind of like get a bit overwhelmed by it, but really it's all about fractions with similar triangles. And it doesn't matter which way you do it, right? Like, say for example, if I have something like 4 and 3, and then say this one is like 20, what is this going to be? So all you have to do for similar triangles, guys, and I know you don't, the only way you can prove that they're similar is by when you actually have all the measurements. All right, if like in this case, we're going to actually use similar triangles to find the question mark, because all we have to do is this, and it doesn't matter which way you do it. And that's the beauty of similar triangles. You could do it like this. If I choose X, if I choose all the lines that are like pointing vertical, if I go X divided by 3, as long as I put that as 20 divided by 4, then I'm correct. And that's one way of doing it. The other way you could do is 3 divided by 4 equals X over 20. That's another way you could do it. So it's all about matching the right sides, right? Like, so if you decide to go, I'm going to divide this thing by this, then I need to make sure that it equals the long length divided by the short length. So it's almost like thinking about it like this for the similar triangle. Long divided by short equals long divided by short, because that's the long side, or you can actually write it like this: long height divided by short height, long base divided by short base. Okay, and it doesn't matter which combination you go with, then you could actually kind of, you're still going to get that kind of working out. Similar triangles sometimes does pop up as an excellence question. So, and it's such like, yeah, like seriously guys, just this is all you need to remember. And as long as you match those correct values, then you're going to be kind of okay with it. Well, if it is rotated neon, all you got to do is just rotate it back to the original, what it actually looks like when it looks like that similar shape, and then just match up those things. I'm glad to help, Salem. I'm glad to help you with that. Yeah, Toby Nielsen, I think I did explain it that way as well, but sometimes I just like, I forget it, man, because like in the moment I come up with something and then I just let it go. Elizabeth, what I've done is I'm going to be stopping the stream in about 3 minutes, but what I've got for you guys is this. Now, I know that you guys still want to do some last minute prep, And the best way to do this is in my playlist, sorry, in my main channel. These 3 videos, the last 3 videos that I've done, they are really, they should kind of really help you out, because this one here is all about linear equations. This is here all about quadratics. And this is the one that we're just doing right now, which is about exponentials. Those 3 videos should kind of help you guys out. Frederick, it all depends on the situation of the question itself. So you got to really think about the question in real terms. Is this something like I showed you with that example with getting $5 per day versus getting charged for a certain period of time? 0.5, 2x. I think ME, you put that question of like that exponential. 0.5 is just 1 over 2. So you can actually write that as 1 over 2 is this 2 to the power of -1. And that's how that -1 comes to the top. No worries. You're welcome, Tomasi. Salmil, no, I do teach. I'm actually a year 9 maths teacher. Whirlpool, just be careful with it, because yes, you might not get the full grades for that if you kind of like mess up with the step graphs, with the filled in circle and not filled in. So you got to make sure you read the question to know which situation you're doing it. All right, I'm gonna switch over. So as I said, guys, for the remainder of the time, if you do want to catch up on any of the other ones, this is the linear one that I did about a couple of I think it was last week, and then that's your quadratic one, and this is your exponential one. I'm sorry I didn't get enough time to actually go through the tables, equations, and graphs. So I mean, not tables, equations, geometric reasoning one, but I do kind of, I mean, like there's not that many people that actually end up doing it anyway. Plus there is plenty of videos up at my previous tutorials that would actually help you guys anyway. All right, last few comments, and then I will have to kind of go get ready for the next one. Yeah, Milo, I'm gonna finish up shortly, Milo. I know people keep asking what's the best way to get ready for this. Just practice, guys. Like, look, just open up a question paper, do the questions with me, write it down. Don't just watch the video. All right, like if you just watch the video, it will not help you. What will help you is actually taking your maths book out, or taking your paper out, like scrap paper or whatever, and then just kind of start working. All right, start working out on a piece of paper. Carmel, I'm going to be ending in about 3 to 4 minutes, because I've got another tutorial starting at 8:45. The mic, actually, I did get a decent mic, which is this sucker here. I don't know if you guys can see it. There it is. Maybe there. Blue. I think it's called Blue Eye something. Now it's a pretty decent mic, but it's just I forgot to actually move it up to the top. Milo Clay, appreciate it, man. Thank you for that. Nah, you don't need to, mate. Like seriously, you just next time you guys just used to do something else, man. No, Strawberry, I'm not actually doing any kind of private tutoring. Like, look, there's about 281 people here. If I do 1 hour of private tutoring, I help 1 student. But here, I can help about, well, I don't know if all 284 are listening, but like at least I know I've got about 50, 60 people helping. By the way, I know some of you guys might be like, might not be doing level 3, like level 2 algebra. But if you're not doing level 2 algebra, then this might be my farewell to you as you guys head off into the stats domain. But yeah, it's been fun with you guys with the MCAT and TEG. If this is the last time I get to see you, all the best for your exams and all the best for your future. And as I always say, don't be a stranger. Pop down anytime you can. And yeah, we're only about 800 subscribers away from our next t-shirt giveaway. So Yeah, and this thing is like those people that leave, they kind of leave and then they unsubscribe, then our numbers go down again, and then we've got to work a little bit harder to try and get to that 30,000. Cookie, yes. Even if you get the final part of that answer wrong, you could still get achieved for some of your working that you do. So Cookie actually put a very valid point, guys. Don't leave any yeah, don't leave any question MTA, because like sometimes just putting like a little bit of details here and there is actually going to get you an achieved. So those investigative questions, I think if you go and watch the quadratic tutorial that I did 2 days ago, I'll show you there's some heaps of shortcuts on how you can kind of get into the get into that investigative questions. All right. No, I've been like, I honestly I don't even know what's happening with the T20 World Cup. Like, it's been so busy, man. Like I think I've overcommitted myself too much. So it's just kind of annoying, but maybe I will try and watch it. LOL, lol. Go have a look at those 3 tutorials, right? They're all in those 3 tutorials that I just showed you guys, for those 3 main equations that you need to know. You don't need that neat. You're all good. Yeah, look, I had a very quick, brief look at the algebra paper today, and I have to say, yeah, the excellence questions were a little bit tricky, doable but tricky, and I think, like, you know, once you get to this stage, you'll actually know that like it's all about that initial solving of that initial step. All right, once you do that initial step, then the question becomes a lot more easier. Maldog Burrito, I've never done chance and data, and I just won't be able to do it because it's just way too much work for me. No, but Eric, I did look at the achieved and merit questions. They were actually pretty decent, man. Like, I mean, it was just straightforward, the achieved and merit questions. But I think the excellence one was like good. That's a good paper, guys. If you think about it, like if you can do the achieved merit questions and you're struggling with that excellence question, then that's a good paper because that's what it's supposed to do. Oh, thanks, Bishal. No, I don't have any idea what the papers are. Like, I don't even know what's happening with that. If I get 1 merit question in question 1, 2, 3, yes, Junyon, that's correct. If you answer just 3 questions that are merit, and if you get all 3 of those, then you get 15 points, which actually gives you a merit. All right, guys, I'm gonna wrap up here because I know otherwise we're just gonna keep yapping away, and I'll drop a little message tomorrow just to I'll probably will be up pretty early tomorrow morning, but yeah, good luck if I don't catch up with you then, because as I said to you guys, I need to kind of get ready for a level 3-1, and come by next year and just let me know. We'll probably do like just like one of those, what do you call it, just chill out and just have a chat session, maybe in December, like early December, so we're not kind of like stressed with exams, so we can just chill out a bit, just have a conversation and talk about what a crazy year it has been. All right, you guys take care. I will catch you guys later. I'm going to end the stream and I will see you guys next time around. Good luck.